Hey everybody, this is Larry. This is too close to the screen. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about today's poem. We have two poems today. We have the daily poem and the weekly premium poem, so definitely stay tuned for that one and in another video. But it's still very hot here in New York. I am still sweating, and yeah, I don't know, I did squats today, I did bench today, and then I ran like 6-7 miles or something. It's just so hot. But let's take a look at today's poem. 1248. Look, it's 1248. Count number of nice subarrays. Medium poem. Given an array of integer nums and an integer k, a continuous subarray is called nice if there are k odd numbers on it. Return the number of nice subarrays. Okay. Exactly k, right? Oh, and a subarray. Oh, okay. For a second, I thought I was thinking about subsequence, and I don't know. I just get it confused a lot. I mean, I think the thing with this particular problem, right, is that for every odd number, it can only be that's not true, is it? Well, wait, again. It's too hard to think. N is 50,000, but that's fine. We're going to do something linear anyway. But yeah, but I think this is going to be some sort of sliding window. But if you have been watching my channel for a bit, I also kind of count this as contributions, right? So what does that mean? Contributions just means that for each either index or something like this, what is the contribution to the answer? And here, you can just count the number of ways that each number can be the last element in the subarray, and that's how I would consider counting those contribution, right? So here we have n is equal to length of I, and I'll go over what I mean by sec. So don't worry. I know that maybe look like I'm jumping into code, but you know, some of these I don't really have it all like detailed figured out. But the idea, you know, as soon as you kind of write it out, it's kind of straightforward-ish. And here maybe I'll just call it on the right side, right? So then now here is left is equal to 0 maybe, and then current is equal to 0. This is the number of odd. So left is the left side of the window or the range. Current is the number of odd numbers inside the range, right? So I think the thing that is tricky about these sliding window problems in general and contribution problems is just figuring out the loop invariance or just invariance in general that happens as you kind of go on, right? So here, as we process the new range, include the new right, then we want to do num sub right, and then if this is odd, and there are really only two things, right? So if this is odd, then current will increment by 1, right? And and then maybe we have a total is equal to 0. This is the answer we're returning, which is the number of nice arrays or subarrays, whatever, right? So the how do I say this? I'm trying to figure out like a clean way of saying it, but basically the idea here, right? Instead of kind of getting something too concrete per se, we can just get a feel for things, right? For some example, let's play around with this array, and here we know that this is the first odd number, this is the second odd number, and so that before the second odd number for k is equal to 2, the contribution for all the other previous elements are going to be zeros, right? Just because there's no possible way. But then here now, what is the contribution of 1 here, right? Well, the smallest subarray is going to be here, right? So then that means that, but that also means that we have 4 degrees of freedom. And when I say degrees of freedom, I mean that there are 4 choices that we can make. In this case, we can just say it's 1, 2, 2, 1. So that's the first choice. The second choice is making 1 extra element in the beginning. And then the third choice is having 2 extra elements in the beginning. And then the last choice is, and you can kind of figure out this pattern when you play around with these prompts enough. And this is why you have 4 degrees of freedom, because there's 3 things here. So you could choose going from 0, 1, 2, or 3, extend past the 1, right? So this is going to give you 4. And then here, here is the same idea, is that, okay, we have 4, so you have, because we have 4 degrees of freedom again, right? And then same thing for the last 2. And that's basically the idea, right? This is how you get 16, right? I think that makes reasonable sense. I think the idea that I'm trying to think is, so then now, while, I guess I could just use a queue. Yeah, I think using a queue makes sense, maybe. Okay, then, yeah. Because you can definitely, like, do a little bit of keeping track of this number, but maybe just, but, what you want to do is just, keep things simple, right? And then now, because Q now returns, let's just say, the indexes of odd numbers, right, inside the range. So then now we don't need current, because current is just a proxy for the length of Q is going to be the number of odd numbers, right? So that's why we don't need any more. And here, as we do it, then Q that append right. Sorry, my watch is like very tight for some reason. I don't know, maybe it's just so hot. Everything is so hot. Sorry, I'm complaining too much. But I don't have AC in this room because I don't know. Lately, for some reason, in New York, the air quality has been bad and allergies has been bad. So my bedroom has been kind of like a bubble room. So like, and in that sense, like I try to not contaminate it. So like when I go in, I take a shower before going into my bedroom, etc. Just, I don't know, maybe it's a little bit too intense. But in any case, that's what I've been doing to kind of keep my allergies at bay when I sleep, which is most important. But as a result, because my only air conditioner is in the bedroom, I don't have, it's very hot out here. Usually, like in past years, I would have the air conditioner, I let it run, and my apartment is not big enough, so it actually cools down the apartment. But today, not so much. And maybe this season, I don't know. But yeah, and then while length of Q is greater than 0, greater than K, we want to keep it to K, right? So then the invariant is that the range will only go up to K. So then here, we will pop left, right? Maybe I could say, yeah, and then maybe we can just actually update left here. And the reason we want left here is maybe this +1 or something like this, or I don't know. Maybe this is, yeah. Maybe this is inclusive. Maybe that's fine. But the reason we want to do this is that, and I deleted the things. I did delete all the 2s. Okay, fine. It's just to keep track of the beginning of the range of, like, for example, we have all these things, right? It's just that we want to keep track of the first 2, and then we have, like, just keep track of things is what we have. And then now we want to see degree of freedom, right? So degree of freedom. I just put on my watch. Why is my watch being like irritating to my skin right now? I don't know. Everything is just so hot. Okay, so the degree of freedom is going to be equal to the beginning of the cube, because that's the first thing. And then left, this minus left. Maybe it's +1. Well, yeah, +1 for the choice, right? Yeah, okay, I think that's right. And then now, Yeah, and maybe we can even just update it here. Maybe that tries too hard. Let's not prematurely optimize a minor thing, even though we're gonna do this every time. And then now total we add the degree and that's it, right? Because here the invariant is that length of q is 0k. Actually, that's not true, so we have to do an if statement because the way that we wrote it, it might not be right. So in that, like if we're up to here, there's just the queue has 0 items. So okay, so we have something like this, and yeah, that's pretty much it. But once it reaches k, it will always be at least that. I think this should be right. Maybe I'm off by 1. I'm off by 1 a lot. Off by 1 here, huh? What did I have? I have 3. So okay, so here is going q sub 0 should be 0, so then it's just 1. That's true. And then here when it at this left is going to be popped, so this is going to be 0. So then I think this yeah, I wrote this with the assumption that this is the first 2, if you will, but yeah, okay. All right, let's give it a quick submit, and yeah, that's pretty much it. Not too bad. Yeah. I think the key part is just figure out the invariants and figure out how to think about it. I think, like I said, the contribution is probably how I want to think about this problem, which is that for each number on the right side of the subarray, we want to figure out how much contribution has to the answer. And once you figure that out, then everything else is just about answering questions that comes up, right? Like for example, we're like, oh, we should use a queue because we have to figure out the first index and also how many things to the left of the first index that we can use. And I kind of didn't show the full visualization, honestly. I guess I did it in my head, but let's say we have an extra 1, then like this would be a subarray, right? This would be a subarray, this would be a subarray, and then when we go to the next one, we would pop out of this one, but then to get this as the left bound, so that you have this, and since we know where the next one is, which is here, all the other stuff is just the degree of freedom, which we can choose to extend, and that is how I do it. And then the other part is that you can probably write this in a way such that you have degrees of freedom going right. Certainly could do that with the next ones or something like this, but instead the way that I did it is that we sum it up even for even things, which adds up implicitly. So there's a little bit of an asymmetry here, intentionally, so that we can kind of exploit it in not double counting, right? Because if we are doing degrees of freedom to the right, there are cases where if you're not careful, you may double count, right? I don't know if it happens in this problem, but in general. Yeah, so this is going to be linear time, linear space. The deck is going to be linear space. This is linear time. The while loop doesn't do anything, right? Because the queue can only have at most n items. So everything's going to pop once. We're going to push everything once, pop everything once at most. So everything is linear time, linear space. And that's all I have for this one. Let me know what you think. Thanks for watching. Yeah, stay good, stay healthy, stay cool. To good mental health. I don't know. I'll see y'all later and take care. Bye bye.